question says, let M be a square matrix, then which of the following option is true? Well, first we will discard the wrong options by taking some counter examples, and then we will prove the right answer. Okay, so let us start with option B. And before that, let me write the expressions for e to the power m, where m is any matrix. I plus m plus 1 over 2 factorial m squared plus 1 over 3 factorial m cubed, and so on. And we will use these two results. Det of A, where A is any matrix, is equal to product of all the eigenvalues of that matrix I. And trace of any matrix A is equal to sum of all the eigenvalues of that matrix A. So we will use these results. So in case some lambda I occurs 2 times, so we will take that lambda i's twice in this product. Okay, now let's go to option B. E to the power det is equal to what? E to the power product of all the eigenvalues of m. I is equal to 1 to n, and e to the power trace m is equal to e to the power sum of all lambdas. And these two are not necessarily equal. But since I have already told you that I will discard this option by taking some counter example, there is another approach also, which is kind of easier. So let us take m is equal to I. So e to the power det m becomes what? E to the power det m becomes e to the power 1, which is e, and e to the power trace m is equal to what? If this is n cross n identity matrix, then trace m is n. So these two are not necessarily equal for n greater than 1, right? So we can say these are not always equal. So we discard this option B. Now let's go to option C. Let me erase it. Let's go to option C. So trace of e to the power m. Okay, so we can take another counter example for this. Let m is equal to the n cross n 0 matrix. The entry of all the entries of which are zeros. So trace of e to the power m becomes what? Since m is 0, so in this expression all the terms become 0 except I. So e to the power m becomes I. So this is equal to trace of I, which is what? n. And the right hand side is e to the power det m. Det m is what? 0, because this is 0 matrix. So it will be equal to 1. So this and this are not always equal, especially when n is greater than 1. So this option is also discarded. Now let's go to option A. Now let me reveal it that the option A is true. So we have to prove this. Okay. Now before that, I will prove another result, which is if lambda is an eigenvalue of the matrix M and V be the corresponding eigenvector to lambda, then we can say that lambda e to the power lambda is an eigenvalue of e to the power m and V be the corresponding eigenvector of e to the power lambda. So how to prove that? Okay. just write it this way: e to the power m into v is equal to, and we put this whole terms, and we put the whole expression here. So it will be I into v iv, m into v mv, plus 1 over 2 factorial m square into v, and so on. Okay, so iv becomes v, mv becomes lambda, since we have considered this thing. M square v becomes what? M square v becomes m into lambda v. This lambda comes out and it becomes mv, and again mv is equal to lambda v, so it becomes lambda square v. So m square v is equal to lambda square v, so 1 over 2 factorial lambda square v, and similarly this will become 1 over 3 factorial lambda cube v, and so on. So in this way we can write it as 1 plus lambda plus 1 over 2 factorial lambda square, and so on, into v, right? And this is the expression for what? E to the power lambda into v. So from this we can conclude that e to the power lambda is an eigenvalue for e to the power m, and v be the corresponding eigenvalue. Now we will apply these two results on e to the power m. So let me erase it. So now option A, det of e to the power m. Since we know that all the eigenvalues of this is of the form e to the power lambda, so det of e to the power m becomes what? Product of all the eigenvalues of e to the power m is equal to 1 to m. So this becomes what? E to the power summation of all lambdas, and e to the power tracing is what? E to the power sum of lambda. So these two are equal. So option A is correct. So thanks for watching, and don't forget to like, share and subscribe.